Hello everyone. This is Hello everyone. This is Dr. Khalil. Hello everyone. This is Math Majlis with Dr. Khalil. Hello everyone. Welcome to Math Majlis. Hello everyone. Welcome to Math Majlis with Dr. Khalil. Today we will take Chapter 1, Section 1.1, that is classification of real numbers. Section 1, classification. In this section, what we study, we are going to study different types of real numbers. Let's start. The first are natural numbers. This is the first type of real number, that is called natural numbers. What are natural numbers? Natural numbers are counting numbers. That means we use the number for counting purposes. When we start counting, we always start with 1, not with 0. Therefore, the first natural number is 1. After 1, when we count the second quantity, we say it is number 2. We never say there is no number, natural number between 1 and 2. That is, after 1, it is 2. After 2, it is 3. After it is 5, and so on. That means there are unlimited number of natural numbers. That is, never ends. So that's what we call it. In terms of that, there are unlimited, or in other words, there are infinite natural numbers are there. In mathematics, we call it infinite. That means there are unlimited natural numbers are there. And in mathematics, always we denote everything by what you call the symbols. The symbol for the natural number is, we use capital N. Whenever I write capital N, that means I'm talking about natural number. So this is the first type of real number. Let's move to the next one. Second, the whole numbers. What are whole numbers? The whole numbers are 0 and natural number. Just natural number doesn't have 0. So we add 0 to the set of natural number, we get the whole number, and it is denoted by W. So what are the whole number? The first whole number is 0, because if I write it in order, the next whole number is 1, 2, 3, 4, again unlimited. Whenever we write unlimited or infinite numbers, we write just 3 dots. That's meaning there are infinite numbers we have. So second group is the whole number, or the type is where for the natural number we add 0. So these are the whole numbers. Then we have third, integers. What are integers? The integers are of 3 types. Number 1, positive integers. Number 2, negative integers. Number 3, neither positive, that means not positive, nor negative. So there are three types of integers: positive, negative, neither positive nor negative. What are positive integers? So the positive integers are the natural numbers. The reason is here, whenever I write a number, any number A, by default, it carries the sign plus. That's the reason all natural numbers have positive sign. So therefore, positive integers are also known as natural numbers. Negative integer, what we are going to do now, for all the natural number, that is 1, 2, 3, 4, we are assigning negative sign for that. That becomes negative integer. So the first negative integer is -1, -2, -3, and so on. So we have positive, we have negative. And the question is here, what is the one integer? There is only one integer which is neither positive nor negative. So that is 0. So we never assign +0 or -0, because +0, -0 has no meaning, because 0 has no sign. So it is neither positive nor negative. 0 is nothing. Whether it is a positive, negative, immaterial. So we have three types of what you call integer: natural, positive, make natural, all the positive integer assign negatives, negative integer, and there is only one integer which is neither positive nor negative. Coming to the fourth one, rational numbers. What are rational numbers? So let me put in a very simple way. Rational number are of three types. One, terminating decimals. Two, repeating decimals. What are terminating decimal? So remember one thing, that this is a fraction, right? A by B is a fraction, or you can say a rational number. Remember here, A can be 0, but B cannot be 0. This is a rational number. That means rational number are actually the fraction. But you should know that the fraction and decimals are same. They are not different. So that's why I am defining the rational number in terms of decimals. For example, 1 by 2 is a fraction. I can write this in terms of decimal, that is 0.5. So 1 by 2, which is a fraction, 0.5, which is in decimal, the same value, they are one and same. So what I am going to do now here, I am going to define what are terminating decimals and what are repeating decimal. For example, terminating decimals are, what are they? This is, if you write the decimal value of the fraction is 1 by 2, it is 0.5. After 5, you don't get any number. So that means after 5, it terminates, means it stops. 1 by 4, 0.25, that is after 2 you have 5, after 5 there is no number. So that means it terminates, it stops. So therefore 1 by 2, 0.5, 1 by 4, 0.25 are the terminating decimal, and they are the rational numbers. What I am going to do now, let's see What do you mean by the repeating decimals? Repeating decimals, for example, if I write a fraction 1 by 3, and if I write the decimal value of this will be 0.333 continues. That is infinite, what you call numbers we have, and here the number 3 is repeating. The same thing I can write 0.3 bar. That means the 3 is repeated. Therefore, I can write in short 0.3 bar on the top, you can say. Another example here is that suppose if you have 0.12 repeats, then I can write down this as 0.12 bar, because 1, 2 together are repeating. So these are the what you call repeating decimal. Sometimes 2, 2, 3, 3, 4, 4 number are repeated at a time, and they are all repeating decimal. So terminating decimals are rational number, repeating decimals are rational number. So two types. There is one more, third type. They are perfect squares. All perfect square are the rational number. For example, square root of 4, it is 2. Square root of 9, it is 3. Square root of 16, it is 4. Square root of 25, it is 5. So wherever you don't get any decimal value, or if you get the whole number, then such squares are called perfect square. So these are the perfect square, and please remember, perfect square are also rational numbers. Remember this. So one terminating decimal, repeating decimal, and perfect square. These are all three different types of rational numbers. Then we have the last, that is irrational numbers. So remember, the rational numbers are denoted by the letter Q. Now I come to irrational numbers. Irrational number, what are they? Look at it. There are two types of irrational number. Number one, neither terminating, nor repeating decimals. Please remember this. These are the first what you call irrational number. So whenever any fraction, if I write it in decimal, if it is not terminating, not stop, not repeating, then such numbers or fractions are known as irrational numbers. Another one is, in terms of perfect square, remember, they are not perfect square. So anywhere, the numbers which are not perfect square are also known as irrational number. For example, let me see this one, 22 by 7. If I write this number in the form of what you call decimals, then it is going to be 3.14, so on. That means after decimal, no number stop, the number doesn't stop, and no number repeats. So this 22 by 7, which is a fraction written in decimal, neither terminate nor repeat. Therefore, this is irrational number. And we know that 22 by 7 is approximate value of pi. And also there is one more, the number e, which we are using in the base of the logarithms, and this is also a irrational number. If you find the value of this, it is 2.71, etc. So this you can see in calculator, this E is neither terminate nor repeat. The pi is also neither terminate nor repeat. So these are two are irrational number. Then what are the not perfect square? We know that square root of 4 is 2, which is a perfect square. It is a rational number. But square root of 2 is not a perfect square. The reason, the value of this is in decimal, not a whole number. So that's why root 2 is not a perfect square, and that's why it is known as irrational number. So irrational numbers are neither terminating nor repeating decimal, and they are not perfect square. So we have now what you call classified the real number into 5 groups. 1 natural number, 2 whole number, 3 integers, 4 rational number, and the fifth irrational number. Then what we do now, we sum up all into one, that is called real numbers. What are real numbers? All natural numbers are real number. All whole numbers are real number. All integers Z are real number. All rational numbers are real number, plus all irrational numbers are real number. So when I add all the numbers, they form a big group, or you can say real numbers. So real numbers, all natural, all whole, all integer, all rational, all irrationals are real number. So any number given to you is a real number. But there is one exception for these. Number one, we know that we know that 0 by any number is 0. So means a real number, 0, you divide by any real number, you get a real number. But any number divided by 0 is not defined. Not defined means you don't get any real number. So therefore, remember, if you divide any number by 0, even your calculator will give you error. Error means you don't get any number. So remember here, whenever you divide any number by 0, you don't get a real number. Number 1. 2. Square root of 4, it is 2. But what about the square root of minus 4? Remember, here I am taking the square root of plus 4, it is 2. But square root of minus 4 if I take, that inside number is not positive, it is negative. Please remember, you don't get a real number. That means, whenever you take the square root or fourth root or sixth root or eighth root, remember, you of a negative number, you don't get a real number. For example, even this is not real number. Even this is not real number. That means whenever you take here, by default it is 2. If it is 2, 4, 6, 8, 10 and under root, if it is negative, you don't get a real number. But if it is 1, 3, 5, then you get a real number. If it is positive, you get a real number. That means, for example, if I this is a real number because you have a under root negative, but outside it is cube root. It is a real number. Even this, it is a real number. But this and this and this is not a real number. This is a real number because it is positive. So remember this. So exception is that all are real number. Two cases, not real number. Any number divided by 0, not a real number. Square root or fourth root, sixth root of a negative is not a real number. Whereas square root of positive, real. Cube root of negative, real. Fifth root of negative, real. So with this, I complete the section 1.1 theory. Now we come to examples. So I will solve 1.1 section exercises, which is in the lecture notes, page number 12. 1.1 section exercises. Note that in this section we have 8 questions. So I will solve some of them, and rest of the thing I leave it to you. But please remember, any question you have, I mean some of the question I am not doing in this particular video, and if you are having any issues or problems in solving those, please leave your comment, or you can write to me on give the suggestion, and I will do that question again on the the next video. Let me solve question number 3. You are given 3 numbers: 0.45 bar, 1.919293 dot dot, then 3.59. So you are given 3 numbers here. What's your question? In the following exercises, determine which of the given number are rational and which are irrational. So here I am going to identify which are rational, which are irrational. Now you know this. Here 0.45 repeats. Therefore, this is what? Terminating decimal. Therefore, it is rational number. This one, look at this. 3.59. After 9, there is no number. So, sorry, this is now we will solve 1.1 section exercises. In this question or in this section, there are 8 questions. I will solve some of them. First, let me solve question number 3. 3 numbers given: 0.45 bar, 1.919293 dash, and 3.59. So you are given 3 numbers. The question is here: in the following exercises, determine which of the given numbers are rational, which are irrational. So we have to identify in these 3 which are rational, which are irrational. You will know that when I write bar, that means it is 0.4. 4 is not repeated, only 5 repeated. So 5 repeated, infinite. So therefore, this is a repeated decimal. Therefore, it is rational number. Coming to the last one. After 9, there is no number. So that means number stops. Therefore, it is called terminating decimal. therefore it is rational numbers. Coming to the second one, 1.9192, no number repeats, number one. Then also the number doesn't stop because of the three dots here. Therefore, it is neither terminates and nor repeats. Therefore, this is irrational number. So this is how we are going to answer. That means look at the decimal value. If it is repeats, if it is terminate, rational. If it is not repeat, not terminate, then it is irrational number. Going to the next one. Example number 6. A. Root 164. B. Root 169. So now the numbers are given in square roots. And the question is the same. In the following exercises, identify whether each number is rational or irrational. So you know that whenever I am talking about the rational or irrational in terms of square roots, you'll have to just look into it whether it is a perfect square or not. That means when you find the square root of that, whether it has a decimal or no decimal. So if you look at this, 169, if you find the square root of this, it is 13. So there is no decimal value here. So therefore, it is a perfect square. Therefore, it is rational number. But when I do this, remember, when I do this, and you will be getting the decimal value. Look at it, use the calculator, find the square root of 164. Definitely it is not a whole number. So you will be getting a decimal value. When it is a decimal value, it is not perfect square. When it is not a perfect square, it is irrational number. So this is how we look into what you call the square roots and decide whether it is rational or irrational. Coming to the last question, there are 7 and 8, the last two questions. I will be taking, what you call question number 8. There are these numbers, -9, -3, 4 by 9, minus root 9, 0.409 bar, or here it is 0.409 bar, then 11 by 6, then we have 7. So what are we going to know? You are given here 6 number. The question is like this. In the following exercises, determine whether each number is a whole number, integer, rational, irrational, and real. I will add here natural also. Look at this. This one. This is natural number? No. Is it a whole number? No. Is it an integer? Yes. The reason is it is a negative integer. Is it a rational number? Yes. Because -9 I can write as -9.0 decimal terminated, or I will write -9 as -9 by 1, that is in the form of fraction, that we can write in decimal. Therefore, it is also what you call the rational number. Then is it irrational? No. The reason is the moment a number is rational, it cannot be irrational. The last one, is it a real number? Yes. This is the symbol of the real number. Please remember this. Real numbers are denoted by R. So therefore, not natural, not whole number, integer yes, rational number yes, irrational number no, real number yes. So this point you will see this, you do it yourself. In fact, this is called mixed number. So the mixed number, we convert it into fraction, that is improper fraction, and then find the decimal. So this I will give you in the later stage. Now minus root 9, that means it is minus 3. The same thing. It is natural, no, whole, no, Z, yes, Q, yes, irrational, no, real, yes. This one, 0.409. How we are writing? 0.409 is repeating. 09 is repeating. So it is a repeating decimal. When it is repeating decimal, so what is the answer of this? Natural, no, whole, no, Z, no, Q, yes, irrational, no, real, yes. Because if it is rational, it cannot be irrational. Exactly the same way, you have to find the value of 11 by 6 in terms of decimal. Check whether it is terminating. If it is terminating, you say it is rational. If it is not terminating, then it might be repeating, then it is rational. Neither of the two, then it is what you call irrational number. But definitely, it is not a natural number. It is not a whole number. It is not an integer. So only you will have to identify whether it is Q or irrational number. But definitely, it is a real number. Coming to the last number, it is natural number, yes. Whole number, yes. Integer, yes. Rational, yes. Irrational, no. Real, yes. So this is what the example number 8. So out of 8 questions, I have done only 3. Still, if you have any doubts or any question, so please leave your suggestion or your questions in the comment box, in the comment, and I will come back to that question in the later stage. Thank you one and all. So this is the end of section 1.1, the theory and the exercises. Thank you one and all.